My name is Marcin Sodkiewicz, and I would like to tell you a few words today about how we are dealing with serverless in RyanAir on a little bit bigger scale than usually small projects done on serverless. So I'm principal software engineer. I'm working in RyanAir since 2016. Apart from that, I'm blogging, I'm AWS community builder, and I'm organizing meeting in my hometown in Wrocław, Poland, for AWS enthusiasts. Okay, so first to give you a context, so let's talk about right in numbers. So we have at the moment over 3,000 flights, we have more than 550 aircrafts, and we are serving more than 14 million passengers every month. And we are flying to plenty of countries and routes. So we are not to talk about the airline itself, but on the IT side of things. So I'm working in the labs, so it's IT department of the airline itself, and we are one of the busiest travel websites out there, fourth biggest regarding air travels, and we are handling more than 1 billion requests every day. We have more than 6,000 lambdas, and we are serving more than 100 million invocations of lambdas daily, so it's more than 4,000 hours every day. So when we started our journey to the cloud, we were in the data center. So at that point, we had very limited amount of machines. We had monolith deployments. If you're familiar with Java, you know the pain of it. So at that point, we had very limited experimentation options and R&D. And everything you wanted to build, you need to have someone from infra team to support you, of course. And there was a lot of maintenance burden. So first, when we migrated to the cloud, we were using stuff which were more cloud native. So we were not sure whether we are going to stay in the cloud or maybe we will go to another cloud provider. But at that point, we were using stuff like Consul, RabbitMQ, Couchbase, and it was headaches. Basically, we were building a data center in the cloud. This is something that we didn't like a lot. So what we have created was this DevOps culture shift. Like this is something that was very bust, I guess, up to now, even in the industry. So we had the concept that we were running whatever we have built, we were responsible for it, and we had support for infrastructure as a cloud. But we knew that it's not the way to go. So when we have decided that we are going to the AWS fully and we are not looking for any other cloud providers, we have seen that we have major improvement regarding time to market. So one small team could build product and deliver it to the production. From collecting requirements to handling pro traffic was kind of easy, and it was in the same group of people. So this is something that we are seeing even up to date, that we are building more and more products based on serverless, and even with a really small amount of the engineers, we are able to handle prod traffic in the airline. Okay, so why we didn't pick the multi-cloud? It's not necessarily true. We are also multi-cloud. We have some things built on the Azure. We have some stuff on the Google Cloud, but in majority we are using AWS. I recommend to see this run by the Corey Queen. I'm thinking more or less the same, so there's no point in wasting time on it, but there's a lot of good points in there. So at RyanAir, don't worry, I don't want to talk about all of those services. But in RyanAir, we love AWS. We are using the services a lot, and we have this serverless first approach up until now. Okay, so let's jump into the compute. So a few words about this, how we migrated servers. So once we were on the DC, it was back in 2016. We were using, of course, VMs. Then we have this lift and shift migration. So we have switched to the AMIs based on the EC2. And right now we are running Fargate. At least in my team, there are some teams that are running them on the EC2-based ECSs as well as EKS. So if we will compare like the pros and cons of using Fargate, we can see that we have no cluster to maintain. We have no server maintenance whatsoever. We are just planning a capacity of a single task that we are running. And there are some drawbacks of it. So we don't have option to shape our pricing. We don't have option to buy reserved instances. We have only compute savings plans, and our options are kind of limited. And it's a little bit more expensive. But few words on that. So this is some example migration that we did from EC2 to ECS. And we are using heavily spots on production at RyanAir. So this is why, even though we are migrating to serverless option, which should be in theory more expensive, it is not that much expensive. So another thing is migration from the serverful and servers to serverless. So kind of different concept, right? But in 2016, we wanted to go for serverless, but we knew that we need to change something a little bit. So this is kind of all the benchmark done by Tundra, and you can see that Java has these huge cold starts in there, and it is a problem, but not that much, right? AWS states that it's under 1% of invocation is cold start, and it's something that, according to my experience, it's more or less the same. So it's not that big of an issue in case that you are not serving synchronous responses like from API gateway or application load balancer. But there's another point here. So it's really important to have our solutions economical, right? So if we can change technology that we are using and we can pick one of the solutions like Rust, Go, Rust these days, right? Then in 2000, not too much. Then we can see that we can optimize a lot our GB hours usage in the cloud. So this is some benchmark done by Scanner. You can go and watch the details of it, but more or less it's processing the same thing with some example of the code. And you can see that especially for this lower amount of the memory, the Go is really good solution for processing stuff in a serverless way. So back then we didn't know that we would go for Go. So we were looking for some language. So we had a couple of boxes to tick to pick this language. So we wanted to have it statically typed. We wanted to have low cold starts. We wanted to have it performant, easy to learn, easy to write async and parallel code, and supported by AWS SDK. And Go ticks all of that boxes, apart from easy to learn from us at that point. We're not sure whether it's a good choice or not. So we had another idea to maybe go for Node.js with TypeScript, but we decided to go with Go language. TypeScript has this benefit that I guess it's way easier to train someone who is Java developer to switch to the TypeScript rather than to Go. And we wanted to run experiment. We are kind of proficient with Node.js and TypeScript, so we built a couple of serverless lambdas in TypeScript. So at some point, Go was the major language that we were using, and we decided to align all of that solutions and redesign this application rewrite this application from Node.js to Go. So basically, after releasing, we have spotted that duration dropped dramatically. It's much less standard deviations in the processing as well as duration, right? If we will take a look at the same time frame for the same lambdas, we can see that invocations are more or less the same. There are a couple of spikes after the migration, and it affected cost a little bit, but not that much, right? So it's not something that has changed revolutionary our billing, but it's something that improved it, right? And apart from that, we have benefits in terms of duration and amount of invocations, right? So if we take a look at the summary in here, what we can see is that basically we can see that in 2020, there was a lot of lambdas that were used with really the lowest possible amount of memory, which is 128 megabytes. But in 2022, we have seen that, for example, lambdas that were written in Java that we think about going that path, more than 25% are using more than gigabyte of allocated memory. And this is something that I was surprised when I have found out in the community that people by default are using more than 512 megabytes of memory, since we were using usually 128 or 256. And that was due to usage of Go, which is very memory efficient. But it's not always the truth. Sometimes smaller lambda might be more expensive than the bigger lambda. I guess since we are serverless crowd, everyone is aware of it. So there is this power tuning tool that you can basically experiment on your lambda and check if you can save by extending the memory of your Lambda. But since we have already this migration prepared, we know what language we are going to use and how are we going to deal with it. We needed to have this kind of classification of the APIs that will be a good candidate to move to serverless, as well as we needed to know whether it will be profitable or not and have this kind of some justification of putting effort and changing them to serverless. So usually it looked kind of like that. So basically we can see that instead of having like constant higher cost, we can drop our cost kind of significantly. And apart from that, we can see that it's adapting to the traffic itself. We have migrated plenty of services like that, and we can see that it is way to go. But not always, but I will go to that a little bit later. So in a bigger scale on this kind of company, using ARM, and it's kind of good option because there is a couple of percent that you can save. But if you will take a look at the bigger bill, it's some significant amount of money. It's worth to note here that it's important to control throughput in your Lambdas, but it's not even about the noisy neighbor issue and controlling the concurrency in your Lambdas. It's more about the dependencies. We need to think about the dependencies that we're using in our Lambdas, whether it's some kind of database, if it's third-party API, and we need to implement back pressure in our APIs and be mindful of what we are consuming underneath. Okay, and another important thing is to set up alarms. It's really to set up alarms not only on Lambda, but also on its triggers, and have alarms on all of the SLAs and the KPIs that our Lambda have. So what I mean by that, that even if you have your Lambda that is perfectly working fine, you can have alarms so you're observing it. But for example, your Lambda is not invoked because your partner has some problem, or maybe shard is blocked, maybe queue is blocked, maybe something else happened. You also have to be aware of that and react to those kind of things. And now let's go to the situation where Lambda is not that good way regarding profitability. In case that we have really high throughput APIs, Lambda might be much more expensive than applications that are server full, right? Especially that we have a lot of options, like we have reserved instances and so on. But does it mean Lambda is not good for the enterprise? In my opinion, no. So the deal that we have is that what we are doing is that we are using kind extensively CQRS. So what we are doing is that we are handling writes with heavy lifting, preparing of the data and everything in the serverless, where the traffic might be more spiky. We have really nice thing to configure the pace that we are consuming data and to do it a little bit better than doing that in the server full option. And at the same time, we can have like really thin layer of servers that will handle the high throughput on the read. And it brings us to the topic of effective events processing. So this is something that is really important if you want to go that way, right? So right here on the GIFs, we have the comparison of partial failures and not using partial failures in SQS. So it's really important to set it to not retry on successes. It's also very important to create DLQs, to not process over and over malformed messages and to handle them another way. And it's also regarding the thing that I had said before on looking of the triggers that we are using is to create alarms based on approximate age of oldest message. Because in business terms, it means how long it takes to process the message in our queue in general. So this means how effective we are in processing stream of the event that we get. Another way of consuming events that we are using a lot is Kinesis. And here there are some differences regarding handling partial failures and DLQs that I will go into details in a second, but there is one new entity in here, which is bisections. So this means that basically whenever we are consuming some bigger batch of the data, we can do the bisections and divide the issue. This is something that you can see on the right-hand side on the GIF. In SQS, we have this approximate age of all this message. Here we have iterator age. So it means how our consumer is falling behind the latest messages that are available in our stream. So this is also some very important metric to observe in our system. Okay, and since DLQs are working a little bit different on the Kinesis, let's take a look what is the issue with them. So in SQS, whenever a message is going to the DLQ, we are just getting that message in the DLQ, and we can pick it up at any point in time. I mean, up to the retention period, of course. But in the stream processing, as you can see, what we have in here is that we are not getting on the letter queue information about which records were failing, but we have information about the pointer in the stream. So it means that when the retention time of the stream, which is by default 24 hours, will elapse, then basically we won't be able to get this information from our dead letter. So there is a good pattern to handle that situation. And in case that we have reported some failure by Kinesis to SQS or SNS, we can pick that message in Lambda. So basically we are getting in the payload of the DLQ information about the shard and pointers to do this record that we can load, and we can schedule it for processing. So we can use, for example, then Lambda, SQS, SNS, Event Bridge, or we can store it in a bucket. We can do anything with it, but we need to pick it up with, before 24 hours since it came to the stream. Another big important thing especially when it comes to the processing messages which are ordered, is DLQs. So on the GIF, you have a situation that we are processing some message and we have buggy record. We don't have DLQ defined. What will happen is that we will be processing over and over the same message, but at the same time, all the messages that are after it in the stream are starting to disappear. So there's a big chance that at the point that your stream will process further after the buggy record, there will be nothing to process in there, and you will lose a lot of messages. And of course, it's nothing that you would like to do, right? So this is why you always have to have defined DLQ. And it's especially important in SQS FIFO in a Kinesis, where you have blocked order of processing, right? Okay, but since we know how to process these messages, now let's take a look if we can optimize pricing of it. So I've heard many times that Kinesis is expensive service, but is it true? It depends, of course, on our use case. So usually when we have flow running on SQS, we can migrate it to Kinesis. And it's usually something that it's really easily doable. So in that case, on the graph, you can see on the x-axis is the amount of the messages sent during the month. On the y-axis, you can see cost. I've created this calculator. You can, by QR code, go to this calculator. I will post about it in a few days. But basically, this is the calculator that you can go there, put the average size of your messages. You can put the throughput that you are having in your event-based system, and it will estimate the cost of the solution. So as you can see, on a bigger scale, you can see that SQS might be way more expensive than Kinesis. And situation might get even worse in case that you would like to have much more consumers. So if you're adding another consumer to the stream of your events using SQS, you need to put it in a fan-out mode through the SNS, and basically it will double your cost. One thing that is also important regarding events processing is to have this kind of event catalogs. There is this new, I mean, not sure if that's new, but it's the Async API, which is equivalent of Open API for event-based system, where it is a new standard for documenting the events. This is something that we want to do. At the moment, we have this kind of event catalog, but it's based on some documents in Confluence, and to be frank, it's not perfect solution. Another thing that is really important that when you are designing this kind of system is to have this common payload conventions for passing their metadata and versioning. This is especially important if you are building distributed tracing and you would like to make sure that it's passed, as not all cloud providers, not everything is supporting OpenTelemetry, for example, at the moment. And right now, let's go to some case of processing data. Usually we have different sources of the events that are coming to our system, right? In case that we have systems push-based like on the top with the SQS and Kinesis, it's of course nice. What we are doing is that basically we are persisting this kind of events in the batches to Dynamo. We are storing all of our events, and then we are reacting to the DynamoDB streams. Then we have a layer of aggregation. So basically we can put informations in the same document DynamoDB when it comes to our like the same common business key value, right? And then what we can do upon it is to build views for our systems that might be used for different purposes. But the most tricky case here is the bottom of the chart, which is poll-based. So if we will take a look at it, in the airlines world, there's a lot of legacy systems that we can't basically have them to send us events. Sometimes it's expensive, sometimes it's impossible. And basically what we need to do is to create events out of those systems because we don't want to deal with those poll-based systems, right? We just want to have an events and react on them in a serverless way. So what we are doing usually is that we are creating this kind of schedulers using event bridge scheduler, that it's triggering some Lambda that is preparing tasks for us to be processed. That's why, because many times you want to inject something to those tasks that will be generated and do it once in one single point, basically. And what we also want to do is to process them in the shards to make sure that in the same business key, there won't be any collisions later. Then what we can do is to load this data from external systems. And then what we are doing usually is we are persisting this kind of events with the hashes based on the information that are important for our system. But we are not writing them using conditional write that you think that it might be a good option, but we are first doing a read to check that hash, and only then we are persisting that information. This is something important when it comes to pricing of DynamoDB, because it works in a way that even if you will write simple fetch operation and you will update only a single field, you are paying for the whole object. If your object is 75 kilobytes, you are paying 75 WCU, right? If it's 300, it's 300. If it's 1, then it's 1, right? But always you are paying for the whole item. The same thing is kind of important when we are building our DynamoDB databases and we want to use GSI. It's really important to mind what we are projecting as an attributes to different GSI, because in general, it works underneath like a second table, let's say, that it's streamed, and we are paying for everything that we are projecting to this another index. But situation might get even trickier in case that what we are modifying is a key in this other index. Then we are paying double WCU for each of these records, because what DynamoDB is doing underneath is first deleting this item and then it's persisting it again. It's also important about the TTL. I've seen many times that people are using TTL through scheduling tasks, these kind of things. And I know that out of some experiments, it looks like this TTL is working fine, but it's not true story in case of big tables. So in my opinion, TTL should be used only for housekeeping. And if TTL is really important for your business logic to not show some values after some time, you should also validate that value before reading it. What we are doing also with DynamoDB that it's not common, I guess, that much, is that we are caching DynamoDB calls. So this is some case that we have really read-heavy application that we have introduced Elasticache to. So basically, after introducing the Elasticache, as you can see, our cost of this solution dropped. DAX was not working fine for us. It was kind of expensive. It is not a serverless solution, so we also need to plan ahead and so on. And it can't be used with any type of solutions. And also, Elasticache has many great operators that can be used, and also you can cache information not necessarily in the same format it's persisted, which is also a nice benefit. And usually what we are doing is that we are basically reacting to the DynamoDB stream and invalidating keys for that records. It's kind of simple, it's effective. Not, of course, not for low scale Dynamo, it might be not profitable, but for a bigger scale, for sure, yes. One thing that about starting projects, so we have a lot of greenfield projects at RyanAir, and I would recommend to not start project with Dynamo in case that patterns of access to the data is not that important. At least if you are not ready to do a lot of migrations, or you can see on the design that there's some table and there is filter and sorting in there involved, and you know that might be a lot of data. That's a red flags for starting project with Dynamo. And also what we're trying not to do is to not start building stuff with single table design. In some cases, it is a good solution, but I guess only in some cases. Like there's a lot of red flags listed in here, and I recommend reading this article, but by Momento on the topic. Okay, apart from using the SQL database like Dynamo, we are using also SQL databases. And as you can see here on the chart, on the x-axis, you have idle period of the database, and on the y-axis, you can see monthly cost of the database. So based on that, we can see that you need to have more than 80% of idle time of your RDS to be profitable. But the question right now is, so is it a bad solution for enterprise? Not really. We are using our serverless in company, and that's because we don't want to maintain and think about scale of our SQL databases, and it works really well for us. Of course, it's some kind of trade-off because it's not free, right? But we can spend time building software and delivering business values instead of maintaining databases. There are two things that are quite common in the community. Whenever there is a new service in serverless, everyone is disappointed about not scaling to zero. So we have used serverless v1, and it has some problems when with the situation of scaling of database too low. And also there are two cases that I think that are red flags regarding scaling to zero and think about having it in your system. One is that there is usually health check involved in your system. So it means that if we would like to have database that will be scaling to zero, it will mean that also our dependencies have to be serverless. Otherwise, they will constantly ping the database and will be invoking it, right, and waking it up. Another thing is outbox pattern. So it's a pattern that basically what we can do with it is to send notifications after changes in the SQL databases, but with at least once delivery instead of at most once. So basically, in the same transaction, we are persisting information that has to be sent, and then it's pulled from the table and sent to the event stream. This is something that also involves constantly calling the database. Okay, now I would like to tell you about one use case that we have created in our labs. So we had a system that basically had really complex data, which were highly relational, and basically they're heavily used on the website. So the problem we had is that whenever there was change to this data, and basically we needed to invalidate those caches. After invalidating the caches, we had search of requests. So we had to do these things like scaling before invalidation. We needed to put data into the cache before they will be hit by the customers, and so on and so forth, because of the spikes, and we didn't want to have disappointed customers who will have to wait too long for their responses, obviously. It was kind of costly, it was complex, and we had multiple caching layers. What we have come up with is that basically when we calculated the whole cardinality of the parameters that we are using, so all of the combinations that we had, they were below 100,000 values. So what we have designed the system to do is basically we have scheduled tasks after every change to the Lambda that basically was rebuilding all of that content and putting that to S3. So basically what we were doing then is we're scheduling invalidations in the event bridge to invalidate this cache, not after every change, but in some periods. And basically, thanks to that, what we have achieved is that basically we have changed all our query parameters to the path parameters, and we're exposing all of the payloads through the CloudFront. So Effect of it is kind of interesting because we have saved tons of money. We don't have servers anymore. We don't have and no caches, nothing. And apart from that, what we achieved is that we have right now multi-region, because since we are serving data from CloudFront using S3, we can easily fall back to different buckets. We can handle spikes using goodness of CloudFront and S3. Caching is easy. We have also versioning right now. The only issues that we have is that we don't have proper documentation for it for our internal purposes that was previously served by Swagger. It's not applicable to all types of systems, rather low amount of them, which has like really disproportionate writes to reads. And also migration we did in a way that basically we have changed all of the consumers of that API and we had this gradual rollout. If I will have to do it again, I think I will go for Lambda at edge, and basically we'll do these translations on the edge. And I think that will be much more effective. The only drawback of that situation is that basically you need to maintain that Lambda at edge and basically make sure that everyone will switch to the new solution. And this brings us to having DR and going for multi-region. I think this is something that I haven't read too much regarding serverless. And this is something that is really, really nice about serverless in general. That what we have here is that we tend to go for this right side of this DR diagram, but with not incurring so much cost of it. So basically what we can do is basically just go for the multi-region. Still, we will have to replicate the data and pay for it. But what we have is that our compute is active in another region, just ready to serve. Usually what our recommendations are to have another fleet of servers that are downscaled, stopped, or whatever in other region. But here, what we can do is just switch and go. Or what is better, we can serve customers through different regions in general as a normal practice. Apart from that, regarding optimization and the cost, what we are doing is that not in all cases, we also use API gateway with HTTP API and REST API. But what you can see here is the comparison of the price per million calls using those different types of gateways. So in case of ILB, it's obviously much lower. Drawback of the situation is that you need to have these Lambda leads, right? And you have one Lambda that is having routing inside of it, these kind of things. But it's not that bad as it seems, at least in our experience in Go. You have authenticators on low IP application balancers, and you can hide it using WAF. It has a lot of goodies, actually. Of course, if you are not using great features of REST API, for example, with API gateway. And now let's talk I will take a few words about the observability. So if we are going to serverless, what we are building is highly distributed systems. It's really hard to navigate all of that. So what we are doing usually is when we are doing the investigations, we are doing that based on the distributed tracing. We are using OpenTelemetry. And what we are doing is that we are collecting information in our telemetry is using gateway pattern. So as you can see on the diagram, all of that information are going to the same auto cluster, but they're going through different channels. So through public or lambdas inside of the VPC. Regarding public lambdas, it's more tricky, obviously, right? Because we have secret rotations. We are passing special tokens, and we're securing that in many ways. But apart from that, what is more secure about using gateway pattern is that what we are doing is that we are injecting the configuration from S3 to our lambdas, but they don't have any of our keys to our observability vendor, for example, right? So everything stays inside of the collector. Lambda only knows where it has to communicate its telemetries, right? With the simplest possible way. What is also important about the gateway pattern, that what we can do is that we can extend it. We need for it additional layer of load balancing collectors, but what we can do then is to have special rules for sampling. So for example, what we can do is that we can sample only traces that, for example, has really slow response time. Maybe they have errors. Maybe they are coming from application with different tags. We can do anything we want based on the engine rules inside the autocollect. And we are not doing that much work regarding observability on our systems using dashboards. We are using alarms mostly because of the amounts of the services and environments that we have. What is really a problem with alarms is that you can have alarms fatigue. And also it can happen that some alarm will basically come out of your radar. So let's imagine the situation. On the day one, the failure started, right? Of course, it's during holidays or weekend or whatever, right? In the meantime, we had attack, we have outage of our third party, we had yet another attack. And also, this is the day that we are coming back, right? When we have this trigger alarm that is constantly sending us alerts, for example, because it's reporting alerts based on the threshold, right? That it's a little bit above and a little bit beyond, right? All the time. So in that case, what might happen that we will have so many alerts reported that it will be a problem to spot that some alert happened a few days ago, right? And what we can do to do it, to not miss this alarm. What we are doing is that basically we are reacting whenever alarm is happening on an event bridge. We have this rule that basically is filtering this alarm, whether it's applicable or not. And if it is applicable, we are starting step functions. Then periodically, we are checking the status of that alert. If it's still in alert, we are retriggering this SNS, and it's then in your face all the time that you haven't addressed this alert yet. And in case it is okay already, we are stopping this to function, right? Kind of simple, very effective, very annoying. And what we are also doing is that we are collecting audits. So we are storing audits, we are preparing for building data mesh. And what we are doing basically is we are sending all of the data that is audit. So they're not logs, they are events that we need to have for track. And with usage of the data catalog, and Firehose, we are encrypting them, we are batching them, we are partitioning them, and we are putting them encrypted on the S3 buckets, where we can then retrieve them using Athena. A very effective, very cheap way to achieve audit. Very recommended one. And what is also great about the serverless that we can build lots of the system with really small team. We are adding more and more products almost every day, and we are doing that with really small team. We don't have much people maintaining that. We can, of course, something sometimes happen, right? This is why you have this alarm observability, but in majority of the case, we can build lots of systems. And over the years, we have migrated lots of them on serverless stuff like, let's say, even boarding pass for airline was not that big project. I don't even remember that we have spent too much time on it, and it works. It works properly without any failures, and it's very cost effective. But sometimes you have this project that proves that serverless is really great, and you can do stuff that you are not the best at, right? So we had a situation that we had basically we are in highly regulated industry, and whenever technicians are working on an aircraft, they have to document everything. We need to have full documentation for and storage. What we wanted to do is to digitalize it. So basically, we had an offer for really high amount of money from some third party that they wanted to do this project for us. It seems like a very expensive and big project. What we do in a couple of weeks, we have built a simple system that basically, after scanning the documents were sent to the S3 bucket, where it were picked on event by Lambda that was scheduling task on the text track, right? Then we are not paying for the time that Lambda is processing that. We are not maintaining servers for the OCR whatsoever. We just are getting notified that this text track finished its job and what are this result. Then we were categorizing those files in the S3, and that project is way cheaper than dinner, right? Monthly, instead of having fat bill from third party and really big project and yet another vendor to contact in case that something is not working, right? So it seems like a really big win from the serverless. And this is something that I That was the last thing that I wanted to mention. And thank you.
There was so much awesome content in there. I don't even know like where to ask a question on. There's my first one. What after going through all of that, what's like the one or two things you really wish you knew when you started that you've learned that if you could go back and change, you would change?
That lift and shift is the worst possible advice that you can give someone. I think that one and another one. Something like the maybe that do not trust the myths from the internet. Like there was a lot of stuff that proved to be wrong. Like let's say that thing with the kinesis. I remember that when we started, I always heard that DynamoDB is super expensive. It's super expensive. Don't use that service. The same with Kinesis. Don't use it. It's very expensive. But like with all architectural things, it depends on the use case, right? Depends on the scale. The same is what is for with many services, right? I always, right now, I'm thinking that people have this kind of myths, this kind of beliefs that something is, but on the other side, there are engineers who build those systems, and they're not stupid people, right? They know that they are building this service for someone to fit some purpose, right? Also, the people from business that wouldn't let them to build some stupid toys, right? So this is something that I think it's very the critical thinking in like reviewing tools and services in cloud. I can see that one raise hand.
Yeah.
Oh yeah. So yeah, I just first of all, amazing presentation. Thank you very much for sharing those details. I believe serverless and all of these kind of pay-as-you-go models are really, really not only the future, but I do believe it's already here, and many companies are applying that, especially this era of just like paying attention to budget restrictions, and everyone is pretty much on a constraint in one way or another, like pretty much on an economical level as well for many companies. So my question is regarding debugging and logs, because that's something that I've experienced myself over the last year, which I've been like getting more and more into serverless, but not only, but also microservices and Kubernetes, like full as a full-time job. Now with serverless, I've experienced myself just whenever there's like let's say like timeouts on the system or delays in processing or whatever kind of jobs we're processing, especially with serverless, I've noticed, and also the different teams that I work with, we have experienced certain kind of problems at the moment of pinpointing which is the specific function or service that is actually causing the delay in the rest of the system. So because what we have experienced in many times, many cases, like whenever a specific section of the system, for example, within a step function, whenever something happens within a step function, this kind of effect starts to affect another sections of the cloud. So everything or most of the other systems attached to it also becomes slower. So for us, in those situations are really complicated to track down what is the origin of the issue. So what kind of advice would you have for that?
So if you want to track the performance issues, like what I would advise first is alarms. I'm not sure what is the scale of your system, obviously, right? I'm not even sure what you're building, but in general, alarms, in my opinion, are the best because they are reactive. You don't need to take a look at the dashboards whatsoever. And if you will have proper set alarms, you will know which lambda caused this problem. It might happen that it won't be that clear, right? In case that, for example, you have timeout X and it's X minus 1, right? So it's working as slow as possibly, but without triggering your alarms, right?
Yeah.
So it might be a tricky situation. But what I will recommend also is something that I mentioned in the presentation, to watch your KPIs. So for example, if you have stream and you have stream consumer, you need to know that it's getting it's falling behind the processing, right? So you will know that the Lambda that's consuming the stream is most probably causing the delay, right? This is something I will put. And if you want to have this kind of, because I think that what you would love to have is to just go to your observability tool, and you would like to have a trace named Quant's process, right? And you will have it divided by different pieces.
Yeah.
And you can do it with a distributed tracing. But to be fair, it's really hard. If you have systems that are communicating directly, for example, through HTTP, it's fairly easy with OpenTelemetry to achieve. But if you have, like you mentioned, the functions, you have in the middle SQS,
SNS sometimes,
Kinesis, whatever. It's madness.
It becomes really complicated.
Yeah. This is why I mentioned also with the section on the events that it's really nice to have this kind of metadata passed with the events to know what is the correlation. Back in the days, before we went for the OpenTelemetry, we had this problem with the correlation of the informations. In the high volume systems, you don't have correlation, then you always are guessing, right? That's the problem. And so this is something that I will recommend first, to pass correlation ID and proper alarming on your dependencies and on your components. Because I think that the goal of distributed tracing might be hard to achieve in all of that components to join together in a single trace.
Also, even using X-ray sometimes became like really costly, like really expensive as an AWS service within itself. So we also try to migrate to something different.
Oh, remembered me about one thing. So if you are using OpenTelemetry with Lambda and you are not using X-ray, there is my advice to add IAM policy to deny X-ray. So that way you can have started trace, but you are not sending it to the X-ray.
Right. Perfect.
But Juan, like spotting these kind of things and building systems to make sure what is, it's like not a task, it's a journey, you have to do it.
It is a journey, yes. I think that's a nice way to describe it. It's a journey. Sometimes we call it down the rabbit hole as well. Yeah. Thank you.
It's a little bit like security, right? It's not some task, it's just another set of responsibilities.
Yeah, I feel like that happens with every system we design. Like whenever everything is working as expected, it's beautiful. I mean, costly, it's cost effective. It's really kind of easier to follow. We have different graphs and charts, and it's amazing. But when something happens and we need to track down the origin or the root cause of the issue, that's where I think there's also a space for improvement in a way. But yeah, that was my question. Thank you.
Now I guess it's David.
Hey, so there were a lot of great patterns in your talk, and I found myself smiling through a lot of them because I discovered some of those patterns on my own just through toil. I'm wondering, are there any particular patterns that stand out that you discovered on your own that you think could be better documented externally so others don't fall into the same hole? For example, like that Dynamo TTL thing, like you think, oh, as soon as the TTL expires, it's going to disappear from Dynamo. But the reality is it lingers for quite a bit longer sometimes, especially at scale. So are there any of those patterns that you had to discover on your own that you wish were better documented and more?
I'm blogging on Medium, whenever I see this kind of queries, I always try to document them in some kind of blog post and write in comments some blogs that I'm reading, through comments. But I just started to blog like 1 year ago, so it's going. But I have spotted some issues like that were not meant in the presentation. Like one day I have found out that I had a weird situation with my Lambdas that it was not updating some parameters. And I was like, no, I was trying to track it. I created some replicable solution and have found a solution with the extensions applicable on some. Apparently, some of the parameters are not updated every time. Honestly, I don't remember what was the case there. But I have it documented on Medium, and sometimes I'm reading my own stuff. But regarding these patterns that I have presented, I think lots of them, there are the things that we have discovered on our own, but sometimes you are discovering on your own, and then you are reading some article, and you have this aha moment that someone did exactly the same long time ago, and even there is a name for it, right?
Yeah, I hadn't really seen that CloudFront caching too much externally, so I thought I'd bring that one up as something that the free CloudFront cache I hadn't seen much documented.
Yeah, look, this pattern is especially good if you have this kind of data. If you're not changing them too frequently, but you need to have serve it on the broader scale. I think this is something that people are doing with the Jamstack, with the serving front ends, this kind of things. So it is in the wild. People are using that, but not. I haven't seen never the way that someone have changed API for it. Like I think not, of course I didn't do it myself first, right? But I haven't seen like it documented anywhere that frequently. Maybe this is this pattern that might be a little bit shameful, because you are not building proper API, right? You are doing some kind of hacks. Maybe this is why, but it works. It really works, and it's amazing. There's another good thing about it. It's fully testable. You have tested all possible options.
Honestly, I think that one is the sign of a good architect, because you thought about the problem in a different way that a lot of people haven't approached it. I remember reading your blog post on that however many months ago, and was just kind of beside myself because that was such a cool idea. I'd have to give you another round of applause on
Thanks.
that one. I love that one. Yeah. So you didn't mention that it was your site, but you did have screenshots on it a couple times. So I just want to give you props to your website, Marcin, your aws-geek.com website that you built. Can you talk a little bit about that and what that does?
Yeah, so I have started with the website that basically it's also built on the step functions, but there are many problems with the step functions in there because some responses from AWS has more than 200 megabytes, especially with the EC2 pricing. So I had to change it a bit. But in general, what I'm doing there is under covers, I'm loading the pricing for AWS services. I'm building my own data for it that is also available. What is the engine for this website? And basically what it does then, it's taking this process data and shows the comparison of the pricing for different type of the compute. So I have there at this point majority of them, or if not all of them, because I have there Uprunner, Lambdas with ARM and x86. I have their EC2 with different options like reserved instances for 3 years, 1 year, upfront, this kind of things. Also Fargate, like many of them that you can compare with each other whenever you are planning to do something. I remember that one day when I have started working with it on Fargate, and I have spotted what is the price of the Fargate Windows, I thought that I have bug, like what's the pricing? It's crazy, but no, it was working fine. So this kind of things might, open eyes someone to which option to go, and especially I think it's nice thing to check if Lambda is up for their service, because that's my guessing, but I think that the majority of the cases Lambda will be really good enough if you're not really big company. And I have right now built another version of it. It will be aws-geek.com/events. And basically this is something that I have showed about this SQS and Kinesis. So Kinesis and SQS pricing is not super trivial, not like multiplying two values, because we have there, we are paying there for chunks of the data. Like with Dynamo, you have this read for 4 kilobytes, and for write you have 1 kilobyte. And in case of the SQS, you have 64 kilobytes per one request, let's say. And in case of Kinesis, you have 25 kilobytes. So you need to put all those chunks. You have to calculate it somehow. And also you are paying for different things in those services. Sometimes you're paying per request, sometimes you're paying per traffic, sometimes you're paying per shard, sometimes you're paying per whatever. And basically what I'm doing there is that basically you can go to this website, don't think too much about it. You can just put your throughput per second, minute, hour, day, or month, and you can put the average size of your document, and website will show you basically how much it will cost you for the whole month, right? Because sometimes it might happen that you are overspending, and sometimes it might happen that, for example, SQS is perfect solution for you, and there is no point in going to Kinesis. This is actually what happened to us. So we have built this product based on the SQS. It was working fine. It proved to be successful. It's actually some internal processing that basically we're playing with. It didn't happen that it's really successful, and basically we are getting more and more events. And then we have looked at our cost at the end of the month, and we have spotted that we are overspending for the SQS, that it's way too expensive, right? So when we have changed to the Kinesis, we are saving around 2,000 a month. So, it's, if you can save 2,000 a month or not for having the same or even better service, because in my opinion, Kinesis is way better service than SQS, right? Then why not?
I love that you're talking so much about cost, and it's such a product and engineering combination. If you're like in a traditional serverful environment, product just says, I want this that does this, right? But like in a serverless world, products, decisions, and non-functional requirements and all the other pieces can really play into profitability and the margin around how you're using and what you're using, all the way down to pick and go versus X or over Y, or looking at the way you're using Kinesis versus SQS. All of that just plays in so nicely. And I think a lot of people sometimes shy away because serverless is almost a little more hands-on in a lot of ways, but in really good ways, because you have the ability to pick the right thing based upon what you want to spend and how you want to operate. You did a fantastic job walking through how RyanAir makes those decisions, which I think is really a neat approach.
Yeah, we do what we can we are low cost airline. We want to have our low fares as low as possible, right? So this is why we are putting so much attention to it. And I'm just one of the guys of the company, right? We have like plenty of engineers that are doing that day by day, and doing their best to optimize the airline, not only in the IT, even in the processing, in the fuel usage, this kind of thing. So yeah.
Hey, just one request from my side. Thanks for your presentations. I think there were so many QR codes to be scanned from your presentation, so might be a good idea to give us a couple of important things to us.
That's what we asked you to do, Rakesh. Rewatch the video and then catalog them in a blog post.
There you go, man. I scanned a couple of them, but still there were so many of them.
I guess session was recorded, so you can write to me. I can send you the slides. I guess it's not, or I can put that on Discord. It's not a secret.
Yeah, so you have a I don't even know what it's called, a discussion topic in the CFP channel in Discord. You can put your slides and your links in there. That would be great.
Sure.
I have one follow-up question with the costs regarding that you were mentioning. Have you tried like cost prediction, even within the service model? Like for example, you're talking about monthly costs, and sometimes in this particular company, which is like kind of an air travel company, there are specific dates across the year that might be more requested, right? Or more like specific times of the year where you have like more like users like reaching the platform than other times of the year, right? Have you been able to predict sometimes the costs involved in a specific, maybe like for Christmas time or for summertime? Have you been able to predict sometime, or maybe has someone asked you to predict those kind of costs?
It's kind of tricky. We are not predicting costs. We are not doing stuff based on the forecasting of the cost. But there's one thing that I can tell what I plan to do, like for next time. So we have a couple of situations that we are optimizing cost. So after cost optimization, we are seeing that cost has grown, and we feel helpless, disappointed about our actions, and we are wasted time, right? But what we then see that, for example, there was a huge spike in the amount of the request, especially for the case that you said, some promotion, some there are different times of the year that people are buying stuff or they're more active on the website, right? So then what we are seeing that, for example, cost, like let's say, rise 10%, but we are seeing the traffic raised twice as much, right?
Right.
So we saved money, right? And this is something that I would like to achieve in the next, I don't know. Okay, let's not say in next future, let's say. And
That's
I would
good
like
to
to have some value per transaction, right? This is something. This is my dream. Like I know that there are companies that are doing this kind of thing. I listened to one time podcast by Cloud Zero, I guess, that they are building this kind of platform for having that. And I believe that maybe in some time with OpenTelemetry, it will be, some kind of injected from the SDKs. AWS is sending a lot of information about it. For example, in Dynamo, it says how much capacity units you used, right? If you are consuming a SDK like SQS, you know how much you paid for the request, right? Of course, it will be some sense, right? But if you will collect those metrics, then you can have this kind of prediction. And I know that the Cloud Zero are doing this prediction, but it will be nice that if you could put this kind of cost per transaction, even for, I don't know, any third-party API with some kind of standardized metric across the industry with some semantic conventions in OpenTelemetry, that is something I would love. Because you will know, for example, how much it costs you exactly, this kind of things that customer is doing on your website, right? Customer journey. So you can optimize in the process, not the full usage, right? Because it's not saying that much. Because if you even want to then optimize the solution, you don't know which part of the process of the customer journey through website, what to do first, right?
Yeah.
I talk too much,
Makes
but
sense.
sorry, but
No, actually makes sense. Yeah,
we are
makes
not
sense.
forecasting.
No, that's all. Thank you.
All right. So I unfortunately have to be the guy that cuts us off because we're over time. But Marcin, thank you very much for this talk. Loved it. Super cool to see how you guys made all those decisions and what you landed on at RyanAir. So thank you very much.